హలో స్టూడెంట్స్, JEE, NEET, EAMCET ఎగ్జామ్స్ రాసేవాళ్ళు యూనిట్స్ అండ్ మెజర్మెంట్స్ అనే చాప్టర్ని ఏ విధంగా ప్రిపేర్ అవ్వాలి అనే దాని గురించి మనం ఈ వీడియోలో చూద్దాం. మనకు యూనిట్స్ అండ్ మెజర్మెంట్స్ నుంచి కంపల్సరీగా 2 క్వశ్చన్లు ఎగ్జామ్లో వచ్చేదానికి ఛాన్సెస్ ఉన్నాయి. మొట్టమొదటిగా యూనిట్స్ అండ్ మెజర్మెంట్స్ అనే ఈ చాప్టర్లో మనం నేర్చుకోవాల్సినటువంటి కీ పాయింట్స్, ఫార్ములాస్ ఏవి అనేది మనం ఇప్పుడు చూద్దాం. ఇన్ ఆర్డర్ టు answer the questions from units and measurements, the students must by heart the fundamental physical quantities and their units and their dimensional formula. From the fundamental physical quantities, we can able to derive the derived physical quantities. For example, length, mass, time are the fundamental physical quantities from which the velocity or pressure or acceleration can be derived. Simply, velocity v is equal to displacement by time. Here displacement and time are fundamental physical quantities. By substituting displacement and time units or dimensional formula, we can get the velocity dimensional formula. In the same way, the acceleration dimensional formula can be obtained by substituting velocity and time dimensional formulas in A is equal to v by t. Similarly, force, work, all the derived physical quantities can be obtained from the fundamental physical quantities. There is no shortcut to remember these physical quantities. We have to substitute the fundamental physical quantities in the derived physical quantities in order to get its dimensions or its units. Next, what is arithmetic mean? Arithmetic mean means sum of measurements divided by total number of measurements. Next, absolute error. Absolute error can be obtained by subtracting the measurement from the arithmetic mean. Mean absolute error. Mean absolute error can be obtained simply by meaning or by taking mean to all the absolute errors. That is, delta A mean is equal to mod delta A1 plus mod delta A2 plus so on plus mod delta A2 divided by n, which is nothing but the mean absolute error. It can be obtained by taking mean to the absolute errors. Mean absolute error or absolute error both are always positive and have the same units as measured by the physical quantity. Relative error. A relative error means it is the ratio of mean absolute error and arithmetic mean. We have to find the mean absolute error and mean of the measurements, and then we have to divide with one another. It has no units and it is a pure number. The relative error has no units and is a pure number because it is a ratio of physical quantities of same nature. Next, percentage error. Percentage error can be calculated by the use of relative error. Simply by multiplying the relative error with 100, we can get the percentage error. In addition or subtraction, absolute error in the result is equal to sum or difference of absolute errors. For example, we have 2 physical quantities that are measured. In order to add these 2 measurements, in this case, the absolute error in the result is equal to the sum of absolute errors in the individual measurements. In the same way, in order to subtract the measurements, the resultant measurement is the difference of absolute errors of individual measurements. In multiplication or division, the relative error in the result will be its sum only. It is in the multiplication or division, the relative error in the result is in the both cases will be its sum only. That is, while multiplying or dividing, the relative error in the result is obtained as the sum of the physical quantities which are measured. In calculating the relative error or percentage error, all the powers involved in the formula should be taken as positive only. In calculating the relative error or percentage error, all the powers involved in the formula should be taken as positive only. Next concept is sig fix. Significant figures. The total number of measured and estimated values in the measurement is called sig fix, significant figures. All non-zeros, all zeros between two non-zeros, all the zeros to the right of the decimal point not followed by a non-zero, all zeros to the right of the last non-zero digit in a decimal point are sig fix. Remaining are not significant figures. Next, the concept of rounding off numbers. For example, take a measurement of a physical quantity 4728. In order to round off to 3 significant figures, we have to take out the 8 and 1 should be added to 2. That is 4730 is the rounded or concept of rounding in the case of 4728. In order to get 3 significant figures, here last 0 is not a significant figure, so the significant figures are 473 only. In order to round off to 2 significant figures, the same measurement can be written as 4700. Here 2 and 8 are rounded off. Next, 4.7258 can be approximately written as 4.72 by rounding off to 3 significant figures or 2 decimals, because 2 is even here, so no addition is taken place here. 4.7538 in the case of measurement 4.7358. In order to round off to 3 significant figures or 2 decimal points, 5 and 8 are rounded off by adding 1 to the second decimal point, that is 3. We get 4.74. Here 3 is an odd number, so 1 is added to 3. Next, principle of homogeneity of dimensions. The principle of homogeneity of dimensions says that only physical quantities of same nature having same dimensional formula can be added, subtracted, or can be equated. If 2 physical quantities are equated, then their dimensions are equal. If 2 physical quantities are added, then the 2 physical quantities have same dimensions. In the same way, if the 2 physical quantities are subtracted, then the 2 physical quantities have same dimensional formula. Next, dimensionless combinations. For example, formulas would have the same value in different system of units, because it is dimensionless quantity. In any system of units, it has same value. Next, exponential and logarithmic terms are dimensionless. In a dimensional formula or in an expression, it contains exponential and logarithmic terms, then those terms are dimensionless. Next, conversion of one system of units to another. For example, we have to convert SI units, that is SI unit Newton or SI unit Joule, to CGS units ergs. For that, we have to write the fundamental physical quantities M, L, T in SI units as well as in CGS units. In SI units, M is kg, L is meter, and T is second. In CGS units, M is gram, L is centimeter, and T is second. By substituting the values, we arrive at the final step, that N is equal to 10 to the power of 7. That is 1 joule is equal to 10 to the power of 7 ergs. In this way, we can convert one system of units to another simply by taking the fundamental physical quantities M, L, T in SI and CGS units. To check the correctness of an equation. In order to check the correctness of an equation, first we have to substitute the dimensions of the physical quantities in the left side, and then we have to substitute the dimensions of physical quantities in the right hand side of the formula by simplifying. If LHS is equal to RHS, then the formula is correct. To derive the relationship between the physical quantities which are dependent on one physical quantity. For example, here velocity depends on E and D. Here V, E and D are, V is velocity, E is modulus of elasticity, and D is density. Because these physical quantities depend on the velocity, or velocity depends on these physical quantities, first we have to write down the dimensional formula for velocity, elastic moduli, and density. Now we have to establish a relation such that v is equal to k into e power a into d power b, simply by proportionality. Simply by the proportionality relation, by equating the bases, the powers. If the bases are equal, then the powers are also equal. While the multiplying, if the bases are equal, then powers are to be added. By equating the dimensions of m, l and t on the either side of the equation, we get the constants a, b, and substituting these constants in the expression v is equal to k into e power a into d power b, we get v is equal to k into root e by d. Here k is called as proportionality constant. In this case, k is equal to 1, therefore v is equal to root e by d. Expressing a physical quantity with a new fundamental quantity. That is, a physical quantity can be expressed only with the fundamental physical quantities, that is m, l, t and so on. But here we have to express a physical quantity with a new fundamental physical quantities. Actually, these fundamental physical quantities are not fundamental physical quantities. These are derived physical quantities. But we have to take these derived physical quantities as new fundamental quantities in order to express a physical quantity. Let us express force with pressure P, velocity v and time t. Here P, v and t are not a fundamental physical quantities, even though we have to establish a relation between P, v and t to get force. Let F is equal to P, v, t. Here P, v, t depends on force, or force depends on P, v and t. But we are not aware of how much power is taken, should be taken on P, v and t. So we assume that P power a, v power b and t power c. Now we will substitute the dimensional formulas in left and right hand sides of the equation. Then by equating powers of m, l, t on both sides, we get a, b, c values, and by substituting we get force F is equal to pv square into t square. That is, force can be expressed in pressure, volume and t as force F is equal to p, v square, t square. Next, some note points are given. Let us see these note points. Here E by B is equal to C. E is the electric field and B is the magnetic field. Its ratio is C. C is called as velocity of light. Next, J is equal to I by A. Here J is current density, I is current, A is surface area. Next, C is equal to 1 by root epsilon naught mu naught. Here C is velocity of light, epsilon naught is permittivity, mu naught is permeability of free space. The same formula can be written as C square is equal to 1 by epsilon naught mu naught. Next, root of mu naught by epsilon naught is equal to mu naught into C. Root of epsilon naught by mu naught is equal to epsilon naught into C. The dimensions of charge, Q is equal to R, E is equal to A power 1, T power 1. Here A is ampere and T is time. Next, nu by E is equal to R square. Here R is the resistance. Next, F is equal to QEB, B is equal to F by QV. Here F is called Lorentz force, Q is charge and V is the velocity of charge, B is the magnetic field. Next, some problems also given based on the practical equipments, that is vernier calipers and screw gauge. In the case of vernier calipers, we have two scales, vernier scale and main scale. The least count of vernier scale is given by one main scale division divided by number of vernier divisions, that is equal to 1 by 10 mm, that is equal to 0.01 centimeters. The total reading by using vernier calipers can be calculated as MSR plus VC into LC. Next, screw gauge. In the case of screw gauge also, we have two scales, one is head scale and another one is pitch scale. Head scale is a circular scale and pitch scale is a non-rotating scale. Here LC is equal to 1 pitch scale division divided by total head scale divisions, that is equal to 1 mm divided by 100, that is equal to 0.01 centimeter or 0.01 mm or 0.001 centimeter. Next, if n main scale divisions in a vernier calipers is equal to n plus 1 vernier scale divisions, then 1 vernier scale division is equal to n by n plus 1 main scale divisions. Now least count can be calculated as 1 MSD divided by 1 VSD. Finally we get LC is equal to 1 MSD divided by n plus 1. If 1 MSD is equal to A, then LC is equal to A by n plus 1. Here A is each division on MS, main scale, n is equal to total main scale divisions. For instance, in main scale, each division is 1 millimeter, then LC is equal to 1 mm divided by n plus 1. That is, here n is total main scale divisions, that is 10 plus 1. We get the least count. Next, in this chapter, while finding the percentage error or relative error, we come across some formulae, that is area of the square, area of the rectangle, volume of the sphere, area of the sphere, or volume of the cube, or volume of the cylinder, etc. These formulas are to be by hearted in order to solve the problems. The students must read these formulas in order to solve the problems based on the area or volume or perimeter, etc. That's all about units and measurements. These key points are very important in order to answer the questions from units and measurements chapter. All the best for JEE, NEET and EAMCET students. Thank you.